Do you know what are the basic subsections of a industrial spice deck? Do you know what section in a spice deck that can vary from one EDA vendor to another EDA vendor? In this video, you will get familiar with 3 different spice decks as circuits. We will run all the spice decks using ngSpice by automatically triggering the output visualization through GNU plot. So stay tuned, stay focused. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the structure of a spice netlist. Next, we will talk about a typical spice netlist and its various sections. So, when you are writing a spice deck, that is the spice input file, there will be several sections. So, you will get familiarized with the different sections that generally a spice deck or spice input file has. Next, we will go for the detailed description of a CMOS circuit. First, we will describe, then we will go through the spice deck. Next, we will go to the code and its output of that particular CMOS circuit, which we have described in the previous point. So this will be sequentially described and then the circuit will be shown and its output will be shown to you. However, in other cases, we will not go in such detailed description. Instead, we will directly go to the code and the output. So the first one is the RC circuit, where we will describe the code and show the output in RC circuit. Next, we will go for the spice code and output of a RLC circuit. Now, once we have gone through this PPT, next section we will move into our terminal and we will simulate all these 3 circuits using the ngSpice and we will display the waveform using the GNU plot. So, there will be a hands-on, and in the video description, you will get all the links to download this 1, 2 and 3. These 3 spice netlist you can download at your end and you can run them with the help of ngSpice and visualize the output using the GNU plot. So here we will close our today's episode after doing all these things. So here we are done in the menu. Let us move on to the next slide. Structure of a spice netlist. Here, with the help of the infographics, we will put a small imagery in your mind that what are the sections present generally in a spice netlist. So the first one is title. So there will be a text title and this will be a commented one. Generally, this is the first line of any of the spice file that has the title. That means a short description of what circuit it is. Next, we have controls. So this could be at the beginning of the spice deck or it could be at the end. It depends from one simulator to another simulator. For ngSpice, we will have these controls at the end of the spice deck. As we go through the examples, you can see for other simulators, these controls may be somewhere else. Next, there are sources. That means we have DC and AC voltage sources which we apply on the components will be available in the section of sources. Generally, the sources are defined first and then we start the components because the type of the sources, whether it is AC, DC or mixture of AC and DC, so those have to be determined first and what voltage and etc. Those will be there. Next, there will be models, spice models that comes from the BSIM compact modeling and all those models are supplied by the foundry. So you don't have to code, you have to just include the available models. For the practice of a student, some models are inbuilt to the simulator so that you can pick up those models and directly use them. Additional models have to be included separately, which are provided by the foundry. So those models will be captured in the model section. Without the model, you cannot run any spice simulations. This is a bare essential thing because any spice component has to show its behavior electrically, and for that we need the spice model. In the Verilog A series, and you can refer to the Verilog A marathon, I have talked about the models. The link of that particular episode is given in the description. If you are curious about the models, the compact models, and what is the present day scenario of all these models are described in a nutshell in the Verilog A series in the first first episode and at the very beginning. So you can go there and use the chapters to learn about these models. Link is given in the description. The next section will be containing the components. So there will be two set of components. One is the active components and another is the set of passive components. Generally active components which can amplify or rectify these. That means your semiconductor components, and passive components like resistor, capacitor, inductor, which do not have a property of rectifying or amplifying. So all those components will be there, and there could be mixture of both active and passive components in the component section. So it will be the circuit, basically the description of the circuit with the interconnections among the components. The next section is the subcircuit. Now, some of the components may not be sufficient to operate with the models. In those cases, subcircuit will be there. Subcircuit is a compact version of the component and the model for a particular block, and that block has some individuality as its input and output. So, those subcircuits will be used. In industry, this kind of subcircuit may come from the foundry, or it can be internal to the IP team. The IP team may give you the subcircuit and you can directly use it, or it may come along with your foundry PDK. So what is PDK and all? We already have a video on that. In case you want to know and you are very much curious about the PDK and its components, you can watch the episode. The link is given in the description. So here we are done with this particular slide. So we have 6 different sections. First one is title, next one is controls, next one is sources, then we have very important model, then we have components, and we have special subcircuits. So all these things will be there inside a particular PICE deck. So this is the infographics that can help you to have an idea, but to become proficient in PICE deck writing, right, you have to go through multiple examples and you have to try out your own circuit that is drawn on pen and paper, convert it in the PICE Netlist and run it with, here we are using ngSpice and GnuPlot, so you can use that, and this way you can become proficient in coding of the PICE Netlist or writing of the PICE Netlist. We are done here. Let us move on to the next slide. A typical PICE netlist. So here we will go through the different parts of a PICE netlist line by line. First, we will have a flow chart where we'll show that what are the parts, and then we'll have an example. So side by side, I will map those things. First, there will be title as we have learned in the previous slide. Next, there will be model and simulator options. The very next zone will contain the supply and sources, that is the voltages that has to be provided for a circuit run. The next section will contain the components, that means the circuit detailing, that means what are there, both the active and the passive components as necessary. Next section will have analysis and plotting. This section in ngSpice will have the control option, right? So you will see that, not for the analysis, but rather for the plot one. And finally, we will have an end statement. End statement ends the PICE deck. That means anything you write after this end will not be considered for the PICE simulation. So now we have the different sections of a particular PICE deck. So let me display a PICE deck for your knowledge. Here is a PICE deck. This first line is a comment and this is the title. You can see this is the title. So title is only one line. So here you can write one circuit's description, what type of circuit it is, and you may write if there is some PVT values to it, you can write it. So those things will be kept intact for the person who do not know about the circuit and will get knowledgeable by seeing that particular line. So it is a very brief information about the circuits and its behavior, etc. The next part is the model simulator options. Here you can see there is a statement called include models.lib. So this comes as the include statement. This is .lib, but you can understand this is not the .lib from the STA. This is the .lib for the PICE models. Generally, this may come from the foundry or it may come from the IP design team. Whatever is applicable in your case, you will get it. Then you will have some options. So here in generic manner, I have write 4x, 4y, 4z and 4k. So these will be some words and so this will define the operation of the SPICE simulation. So these options. Don't worry, in this series we will go in every detail of each of these statements. So don't worry. In case we want to include some models will be there. So this particular section here, you can see it is completed using this type of commands, and generally it is at the top after the title. The next section is supply and sources. Now let us see what are the voltage supply. We have a comment here. The comment character is star, that is the asterisk that makes a line comment. So in case you want to comment a line which you are not using, you can use the star also, even anywhere in the PICE deck. So here you can see there is a pulse train. So we will go in detail of all of these sources. Here I will not go in minute details, rather I will describe here what is there. So here we have a source where we have voltage value and we have pulse train here, you can see, right? And then we have a AC value, right, where we have a sign, and these are nodes. So data 0, these are nodes of the circuit. So the nodes could be alphanumeric, either they could be numbers or they could be the small words. And here another one is the exponential. Various kinds of voltage supply, that means one particular supply will be the basic DC level. Generally a circuit needs a DC part to get turned on, and on top of that there could be a pulse train, a sine wave, a exponential wave, anything like that, that actually determines the operation zone of that particular circuit. All those additional sources will be applied. So there will be a DC, and in addition there will be a different kind of waveform of the supply. It could be pulse train, it could be sine wave, it could be exponential, anything, or it could be a periodic one that is written with the PWL. So all those things will come later. So we can conclude that this section corresponds to the supply and sources. Supply means the basic voltages that will help the circuit to turn on, and the sources means it will act as a stimulant for that particular circuit. The next section is the circuit components. Here you can see we have the circuit components, and here we can see that up to this part, and here we can close it. So here we have the particular component L. Generally we have the type of the component by its initials, right? L is the inductance, C is the capacitance, R is the resistance. It could be also alphanumeric. Okay, we will go in this nomenclature details later episodes so that you will have the proper knowledge about all these things. Then there will be nodes. There are two nodes, and then there is the value. So here, so no value is written. So there are some default values to it, and we will also discuss in later episodes. So here we will not go in that much detail. You can see the circuit components here corresponds to the component section. So this also has a comment which we have created with the asterisk. So now the next section is the analysis and plot. So here we have transient analysis. And we will go through the detail of all of these transient AC and DC analysis types in later episodes. You have to stay tuned for that. And you can see there is a plot command here. This plots. But however, for the GNU plot to get activated, we have separate plot commands, and that is what I am saying, because these things may vary from one particular simulator to another particular simulator, because this plotting involves a separate GUI window to come up with the plotting of the data which has been achieved by the SPICE simulation. So here you can see there is a print. It will print the data in the console. That means the terminal that you are using to run the SPICE deck. That means the SPICE input file or the SPICE netlist. And here you can see there is a end statement. So anything after this will not be considered the part of this particular SPICE netlist. So if you write any components after this, they will be discarded. So end means here our SPICE netlist is ending. So this is the very simple example of a SPICE netlist, and we have segregated the different sections, that is title, model and simulator options, supply and sources, components, analysis and plot, and finally the end statement. So any circuit will follow this pattern. In addition, there could be some plus minus things that will vary either from design to design or from one simulator to another simulator. That you will get educated once you start the SPICE netlist coding, or you enter into the VLSI industry. There you see any particular SPICE netlist, you will see some additional things. Now, one thing I would like to say here, from one EDA vendor to another EDA vendor, there could be some changes in inside this particular spice deck. They will be somehow similar. In addition, there could be some differences maybe in some of the area. Okay, so while you are defining, there could be some of the commands that could be different from one vendor to another vendor. You have to be careful about that because there are several EDA vendors and all of them provide spice tools for the simulation. As in the previous episode, we have talked about the pure spice, accelerated spice and the fast spice. These three could be from three different vendors. They might have some intrinsic difference of having the spice netlist. So you will get familiar, don't worry, you can consult the manual and there you will get some examples and all, or the tool installation folder may have a examples folder. From there you can get educated. That is not a cumbersome thing for you. Here I am touch basing the facts so that you are not get lost once you enter the VLSI industry. We are done here. So let's move on to the next slide. The spice description, the CMOS circuit. So in the upcoming slide, we will show you a CMOS circuit. Since CMOS is the kind of unit block of the VLSI chip, right? So here we are giving a short description what you will see in that particular spice deck. We'll go in a very speedy manner so that you can reach to the spice deck in the next slide and you can correlate. So here goes our spice details. First one is the voltage sources, right? Next will be the voltage sources. Here is the VDD, supply of 5 volt. Next, Vin, the input voltage of a pulse train of amplitude 1 volt. So you will get all of these things in the upcoming CMOS circuit. Next, we have transistors. M1 is the NMOS transistor with source connected to the ground, gate connected to the input, that is in, and the drain connected to the output, that is out. Basically, this is a CMOS inverter circuit. So in is the input of the inverter and out is the output of the inverter. The NMOS transistor has a length L of 0.5 micrometers and width of 1 mic. You can vary or change them as you wish in the spice deck and see what are the result of those changes. Next is the M2. M2 is the PMOS transistor with source connected to the supply and the gate connected to the input, that is in, and the drain is connected to the output out. The PMOS transistor has a length L of 0.5 micrometers and the width of 2 micrometer. So here you can see it is 1 and it is 2. There is a reason why generally the PMOS has a larger area. You can find that fact in your textbook. Why this? I can give you a hint. It's related to the whole mobility and the speed of that particular carrier. So can you do that? Can you find the answer why the PMOS has a double size or larger size from the NMOS? Next, we have the load capacitance that acts as a load for the output. So we have a C1 load capacitance of 1 femtofarad connected between the output and the ground. So this will act as a load because generally the PMOS circuit will fade into some output, and here we are considering a capacitor as our output, and that is called the load because that takes the input from the output of the CMOS circuit. Next, we have the analysis. We have a transient analysis of 0.1 nanoseconds to 10 nanoseconds. So we have a transient analysis there. So this is the quick description of the spice netlist of a CMOS circuit. In the next slide, we will go through that particular spice netlist and you have a quick impression of all these things in your mind. So now let's move on to the next slide. So here we have our CMOS circuit. This is our CMOS circuit and you can see there are several sections which you have learned from the title up to the end statement is also present here. You can relate by yourself, but let me point it out for you. So here the title is this one, the CMOS inverter circuit. The next we have the two model statements which goes to this particular section. That means the models and simulator options. And here you can see the NMOS, PMOS levels are there. That means these are the BSIM levels which I have talked about earlier, which you can learn about from the Verilog Marathon. Link is given in the description. So here you can see as we cross this model section, then we have the supply and sources. So here we have the supply and sources. So this is the supply. This is the basic DC supply that will energize the circuit. And this is the source. That means it will act as an input stimulant to that particular source so that we can have a corresponding output and we can compare whether our circuit design is correct. So this is the section of the supply and sources. In the next section, we have components. So here you can see three components are there. First one is M1, that is the NMOS. Next one is the M2, that is the PMOS, and we have a output capacitance T1, that is the load capacitance. So these are the components. So these two are active component, and here is the passive capacitance, which do not have the capability of amplifying or rectifying a signal. So here you can see the total components. Three components are there. We are done with the component section. Next, let us go to the analysis and plot. So plot will be later on. Here we have the analysis, right? The transient analysis. The transient analysis start from 0.1 nano and it goes to 100 nanosecond. So our analysis part is here. Now let us look into the next section, which is very unique to the ngSpice and GNU plot combo. I have emphasized this point that this control part will be different from one simulator to another simulator. So the control part for this ngSpice starts with the control statement and ends with the NC, that means the end control. So in between anything could be there, that will be for the control part. So OP will be the operating point analysis, then run it, the simulation will run, and then it will call the GNU plot with a temporary file GP. GP will contain the data. GP will have some extensions. This is the prefix, and there will be some extensions of the files. Once we run this, you will see that instead of GP you can write something else, and then the GNU plot will plot the V out. Out means this particular node. Let me see this out node, and V in, that is the input node. Where is this one? So these two node voltages will be plotted in the GNU plot in the same window, and here our control ends. So the control block, rather than this is plot block, so this is the plot one. The plot one is here. You can see analysis was there, it is earlier. So analysis and plot section is done. Next we have the end statement. Here is the end, right? End will end the spice deck, and once we run this using the ngSpice and the GNU plot, we'll have this kind of output. So there will be a V in, which is a pulse, right? And again we have a V out, which is again the pulse, but they are in inverted form because they are going through a inverter which inverts the voltages. That means it will convert one level to the zero level. That means it will convert 5 volt to 0 and 0 to 5 volt. So you can see here the waveforms of different colors. So V in and V out, you will see in greater detail once we run this by hand at the end of this slide. So you will see there. And this is the kind of output of the GNU plot, which has been triggered from inside of the ngSpice. So this will be fed to the ngSpice, and automatically the GNU plot will be called by this command, and this output will come. So you see that we're done with this particular example. Let us move on to the next example. Here we have the spice code of a RC circuit. Now let me display the code, and let me segregate the different sections. So this is the title, which goes for this particular title part. Now we don't have model sections, but we have some simulator options. That is the param is here, right? So this belongs to this, the second one, the simulator options. Okay. And we have supply and sources. So here we have supply and sources section. So that is the VDD, and we have a AC voltage here. And we have commented this, since this circuit is a passive circuit, RNC, it do not need to get energized with a DC voltage. Okay. The previous circuit was active component, and that needed some voltages to be applied to them to get activated, but this do not require that. So we can directly go to the sources. Here is the source, that is the input source, which will provide the input variation so that we can get a output variation. Okay. Next we have the component section. Here it is very short, R and C in series, right? So we have C and R here as components, and you can see this param res is defining the resistance value. So you can change here and it will get automatically passed on to this particular resistance value. The component section is done. Next is the analysis and plot. The analysis is here. It is the AC analysis. So AC has its nature of defining. So it is a decade. We will go in the detail of this kind of analysis later on some other episodes. There will go detail on how the AC is defined and what are the different components of a AC or transient or DC. So you have to wait for that. Here we will not go in that much detail. The next one is the plot or the control part. Here the control starts with the dot control command and ends with the NC. So here is the OP again, as similar to previous spice deck, and we have run similar to previous spice deck. Again we are calling GNU plot. We have a temporary file GP. This is the prefix, and we'll have some extensions to store the data that can be used to display the data in the GUI window. And here this particular node, the output node, the voltage will be shown in the output as a plot. And here at the end of the netlist, we have the end statement that ends the spice deck. So we have all of the things here. Here you can see that the things are a bit jumbled up inside the spice netlist. That means all these sections are not in sequence. So you have to face these things in an industry, and you have to get prepared that all the sections will not be in the sequence, but however all of these sections will be present either directly in this particular file, or there will be a .include statement, and you will have another file which is pointed by this include statement, and that file will contain all the details. You have to mentally prepare for that situation. So once this code is run, that means once this spice file is run through the ngSpice and the GNU plot, this kind of waveform is generated, and you can see this is a logarithmic scale here this way, and here we can see the output is swinging like that. This is the AC analysis. This is the RC circuit, right? So you can see it is a low pass filter kind of thing, and as the frequency goes over to a particular frequency, it is attenuated. So this is a kind of low pass filter circuit. We are done here. So let's move on to the next slide. Spice code and output of a RLC circuit. Without any further words, let us have the circuit. So here again we have the spice circuit. Again we will have all these sections. Let me map these sections for you. The first one is the title. Next, we do not have models because these are passive components and we don't have any simulator options here. So this particular section is not present here in this particular deck. So this is another option that you can face. Next we have the supply and sources. So here you can see we have a AC voltage here, the AC sine waveform that acts as an input. This is here. So this is the supply and sources section. Next, we have the component section. So component here you can see R, L and C. This is a RLC circuit. So this particular components are passive components and they do not need a DC voltage to get energized. So the DC voltage source is missing here. Here the component section is done. Next we have the analysis and plot. So analysis, we have transient analysis. So we are giving it, and for printing, right, we have the print statement here. One mistake is here that this particular end has come. This should not be here, as the end statement will come at the end, and here we have the end, right? So this is one mistake here. Now next one is the plot section. The plot section is the control section, starts with the control and ends with the NC. So here we have OP, run and GNU plot command similar to the previous spice deck, and here we have voltages 1, V1, V2 and V3 for displaying, and at the end you can see here the end statement ends the spice deck. So once we run this circuit with the ngSpice and the GNU plot, we get this kind of a output. Okay, so there are some of the voltages are overlapped. You can see the sine wave is going through, right? This is a kind of transient response of a RLC circuit. You can do any changes here as you like, and you can run it again to get the different kind of outputs, and you can store the old output as snapshots to compare them. Okay, or another thing you can do, that you can change the GP to something else so that the database for the GNU plot changes. Here we are done with the 3 examples, and now we will move on to our terminal to run this particular spice decks by ngSpice and the GNU plot combo. So let us go to the terminal. Welcome back. We are in the terminal here. Let me do a ls here. So we have 3 different circuits that we have just shown in our slides. So let me open each spice file. We are using gvim and the alias is here G. So don't get confused. You can use your own text editor to open this. So let me open the CMOS circuit. You can see we have this particular CMOS circuit along with the control statements for the GNU plot, as we have seen in the slide. You can download this spice deck from the link given in the description. So go ahead, download it, and you can run as I am going to show. So let me close it and let me use ngSpice. So before using ngSpice, let me check where it is installed. So I will type which ngSpice. It is there in the user bin ngSpice. So in this path, the ngSpice is there and it will run from there. And next, let me check for the GNU plot. So here it is GNU plot. we have a separate episode where I have shown the installation of ngSpice and GNUplot together. The link of that episode is given in the description of this video. In case you do not have these two things installed in your system, go ahead, see that episode, install these two binaries in your Ubuntu Linux, and then you proceed for trying out the two examples. Let me proceed as we have the two different binaries installed in the system. So let me run the Spice deck. I will type ngSpice followed by CMOS and I will hit tab. The deck name automatically comes as we are using the TCSH. And you want to learn about the TCSH, we have an entire marathon on Linux. The link is also given in the description. You are not familiar with the Linux, so please go ahead and learn the Linux because it is very essential in VLSI. Now let me hit the enter and you will see the magic. So let me show you what has been gone through in the terminal. So once we have run the Spice deck using the ngSpice has first turned on and it says no compatibility mode selected. It is unimportant right now to us, but it could be in case some Netlist compatibility thing you have to incorporate. In that particular case, it will be important, and we are skipping this at this moment because we are going through the very initial stage of running the Spice Netlist. Now, if I go down further, you will see that the circuit is a CMOS inverter circuit. This comes from the title, and here it has run. All the steps have been printed in detail. What the values are there, the transient time started at 0, then the temperature is this, T-norm is this. All these details are there. These are not needed until you face any error. If you face an error, you need to look at this particular log. Some of the Spice tools generate a .log file containing this informations. So once this is done, ngSpice terminal has opened here. You can see, although it has executed the control commands as we have given, and here is the GNUplot. Let me expand it. So you can see here that V in is in green color and V out is in purple color. So you can see the input as it goes like this, right? The corresponding output goes like this. So it is acting as an inverter, and this is true for all these sections. So you can see all these sections are behaving very similar fashion. So the inverter is performing as it is expected. So we are done with this particular GNUplot. I'll close this window. To store this, you have to take a snapshot. Now we are done. Let me put an exit here from the ngSpice terminal and let me do a ls again. You can see there are some files, gp.data and gp.plt is there. I think the plt corresponds to the plot. You can rename it, or you can give a separate name gp. Instead of gp, you can give a separate name in each of these decks and you can save all this data. Okay, that is up to you. For me, I'll remove these two files and I'll go for the next Spice netlist. So let me do the cleaning. Now let me open the rc.sp, that is the RC circuit. Here it is opened and you can see it is very same as you have seen in the slide, and even this commented part is also same. You can download this. The link is given in the description. From there you can download it and run it as is. And here is the control part for the simulator ngSpice to invoke the GNUplot. So let me run it. We have ngSpice, then rc.sp. But before that, we have to clean the GP files. Let me do a rm gp then star. I am removing all the GP files here. So now again, let me do the ngSpice and do rc.sp. And once we hit this enter key, you will see the magic and it's there. Again, you can see here in the terminal, right? You can see here all the details are logged here from the Spice run, right? Which is necessary only when you have a problem and you need to look where the problem is coming from. That time you need to go back and see this particular log. And now the output is there. Let me maximize this and you can see here that it is acting as a low pass filter. That means up to some frequency right here, it is passing everything, and after that it is attenuating the output. So we are done here analyzing the output. So let me close it. Let me put a exit. We exit from the ngSpice terminal and let me remove the GP files. I have removed them and let me clean the terminal, and here Let me do a ls. So remaining is rlc.sp. Let me invoke using the ngSpice. Before that, let me open and show you that this is the same file that we have demonstrated in the slide. So you can see here, these are the components, then it is the sine wave voltage, then it is there, and it's same because we have a end statement. Even the mistake is there. You can see the end. Let me remove this line by inserting a asterisk here. So the end will be at the end of this spice deck. Everything remains same. Let me close it and let me run it. Let me type ngSpice followed by rlc, and once I hit enter, it will do the magic. So you can see here the ngSpice has run, and here is the log. You don't need this log until you face any error. So here you can see what has been gone through. Okay. Now let me go directly to the output. Here let me maximize it. Here you can see there are three outputs, V1, V2 and V3. Some of them are overlapped, so we can see only two of them because any two of them is overlap. So can you find which one of these two are overlap when you run the spice deck? You do that and let me know in the comment. Three waveforms are there in this particular LCR circuit, and we get a output like this. So we are done here in the GNU plot. So let me close it. And let me exit from the terminal. We are done. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.